Parameters for pass number 1. Set travel speed at 17 inches per minute. Wire feed rate 500 inches per minute. Oscillation width 62 thousandths of an inch. A frequency rate of 270 oscillations per minute. Dwell time 150 milliseconds. Arc voltage set at 23. Now, parameters for pass number 2. Travel speed 15 inches per minute. Wire feed.
From man's first discovery of oil and natural gas and his development of their potential, he's been struggling to bring them closer to the people of the world. Since the early 1900s, H.C. Price Company has been an innovator in the development of pipeline construction technology to help move energy from the field to the consumer. The Price Company pioneered electric arc welding of pipelines, and later the double jointing pipe welding technique that's become an industry-wide practice. They advanced the use of the internal lineup clamp and other innovations, including the semi-automatic handgun wire welding system. As technology advances and environmental safety standards are stiffened, pipeline construction and welding procedures are scrutinized more carefully. Today, no other high-production welding in the world meets such demanding specifications and intense inspection. After years of research and testing, H.C. Price Company has developed an automatic pipeline welding system designed to meet the industry's exacting standards. Price automatic welding system was first utilized aboard one of the world's largest semi-submersible pipe lay barges, the Viking Piper. As its initial project, the highly sophisticated computerized 500-foot vessel completed 102 miles of 36-inch pipeline. The pipeline stretched from the Shetland Islands through the treacherous North Sea to the Ninian Field. The H.C. Price automatic welding system proved to be ideal for use on the lay barge. It incorporated the most advanced techniques, permitting multiple pass welding under the guidance of precise, preset electronic controls. With the ship's daily operating costs measured in hundreds of thousands of dollars, the accelerated welding rate and the constant high-quality weld achieved were important economic factors. The Viking Piper was expressly designed to maximize the effectiveness of automatic welding. A double jointing line on the barge, utilizing Price automatic welding machines, permitted the barge to move in 80-foot increments rather than the conventional 40-foot moves. This procedure sharply increased the pipe-laying speed of the huge vessel. 3 automatic welding stations were utilized on both the double jointing and main welding lines. At the first station, the root pass, hot pass, and 1 filler pass were deposited. The barge was advanced, and while the process was being repeated at the first station, the second welding station applied 3 additional passes. At the third station, the weld was completed. Throughout the project, the Price automatic welding system was constantly evaluated under the stringent standards of the British Petroleum Company. The durability of the Price equipment while making automatic multiple weld passes was impressive. So too was the enthusiasm which the welders and technicians had for the equipment and the manner in which they operated it at a high rate of production. The success of the Price automatic welding system can be largely attributed to its high degree of repeatability. One operation essential to that uniformity is the end preparation of pipe joints. A special end prep machine takes the standard factory 30-degree bevel or the field flame cut bevel and machine cuts a new joint design on the pipe ends. The new design is the result of much experimentation and analysis by H.C. Price welding engineers. It utilizes compound bevels that are varied depending on pipe wall thickness. Use of compound angles tightens or narrows the traditional 30-degree factory bevel. The resulting steeper angles effect a savings in time and material by greatly reducing the amount of weld metal deposited during the welding process. A machine cut design also provides the more uniform joint necessary for consistent quality in automatic welding. Use of the end preparation equipment serves to clean the joint as it cuts, eliminating rust or other contaminants on the welding bevel. The end preparation tool gives the welding engineer the flexibility needed to optimize a joint design to accommodate the welding of all pipe wall thicknesses. Once end preparation has been completed, the pipe section is ready for alignment and welding. With the Price automatic system, all welding is done from the outside of the pipe. This eliminates remote operation of in-pipe welding equipment for application of the root pass. An integral part of the Price technique is a specially designed multi-purpose lineup clamp. It not only performs traditional lineup clamp functions, but also controls joint spacing automatically and provides a welding backup. In a single operation, the pipe ends are brought together around the clamp, aligned, butted, clamped tightly, all within seconds. Then the exclusive spacing feature of the lineup clamp separates the joint automatically to 80 thousandths of an inch. Hydraulic cylinders separate and maintain this predetermined distance with a force of 60,000 pounds. Specific joint spacing is required in automatic welding, since certain functions, including weld metal deposition, have been pre-programmed and preset. Automatic spacing aids in repeatability and uniformity of welds all along the line. Another exclusive feature of the Price lineup clamp is a hydraulically controlled copper backup ring, differing sharply in design from traditional backup rings. From the outset, emphasis was placed on elimination of weld contamination. The unique design limits the number of ring segments, with the hinges and segments located so as to avoid the critical top and bottom points of the weld pass. Two of the hinge segments slide with one another, providing for expansion or retraction in the ring. The backup ring is driven hard against the inside diameter of the pipe by a hydraulic system within the clamp. The ring contributes greatly to the welding of a uniform joint. During welding, the molten weld puddle serves as a barrier between the welding arc and the backup ring at all times. Electronic control features of the automatic system assure that weld travel speed and wire feed rates are held constant at their predetermined settings in order to maintain an insulating weld puddle. With the pipe firmly clamped and positioned and the backup ring in place, 4 automatic welding heads wait in home position for the operator's push of the start button. Operators on each side of the machine use remote controls to align the welding torches over the joint. Each operator has a control panel providing fully automatic welding capability. With manual override and emergency stop provisions, he can interrupt any operation at any time should the need arise. To initiate the automatic welding sequence, the operator simply turns the pass selector switch to pass number 1. Then, when ready, he pushes the automatic weld start button. A ring gear assembly containing torch heads 1 and 2 rotates in a reverse direction to weld start positions at 0 degrees and 90 degrees respectively. Torches 1 and 2 start welding downhill simultaneously. The welding heads are mounted 90 degrees apart, and each torch will weld 1/4 of the pipe's circumference, with overlap and sequence pre-programmed. After torches 1 and 2 have progressed a predetermined distance, the ring gear assembly automatically rotates torches 3 and 4 to their weld start positions. When in place, they begin welding their respective quadrants. Now, all 4 torches are welding, each controlled electronically by the master control unit. Welding voltage, travel speed, wire feed rate, oscillation speed, width, and dwell are all precise functions preset in the controller. Each welding torch is programmed for a 1/4 inch overlap with the torch of the adjacent quadrant. This procedure provides good penetration around the entire circumference of the pipe. After completion of each welding pass, the torches are automatically shut off and return to the home position in preparation for their next pass. The start and stop locations of each weld pass are staggered to assure complete fusion and avoid excessive weld buildup. All functions are predetermined and programmed according to the individual requirements of each pass. As a result, the machine provides the capability of multiple weld passes, each with a different set of welding parameters. The operator rotates the pass selector switch to the next pass number and pushes the automatic weld start button. This initiates the entire welding sequence again. Subsequent passes may be run at an entirely different travel speed, wire feed rate, and oscillation width. The number of weld passes required is a function of wall thickness. The efficiencies realized by automatic welding are maximized as wall thickness increases. As a general rule, the automatic system requires 1 weld pass for each 1/8 inch wall thickness. For example, a 3/4 inch wall would require 6 passes to complete the weld. The price system can be adapted to weld all pipe diameters, ranging from 16 inches to the largest of the big inch pipe, and for all pipe wall thicknesses. To compensate for irregular surfaces on the pipe and pipe coating, the welding head assemblies are mounted on special out-of-round units. The units rotate around the pipe on wheels, maintaining a constant contact tube work distance. The welding arc is shielded with a mixture of argon and CO2. The system incorporates gas mixers that permit varying proportions of argon and CO2 and the use of bulk supplies. The welding torches can be easily removed for cleaning spatter off the nozzles. All electrical and mechanical components of the system have been designed for easy removal and replacement, minimizing costly downtime. On most assemblies, the operator need only loosen 4 bolts, unplug a quick disconnect, and lift the assembly out for replacement if necessary. Because the needs of each project differ, automatic welding parameters must be established prior to starting any job. H.C. Price engineers develop custom design programs through research, testing, and metallurgical analysis. Samples of project pipe undergo procedure qualifications testing. The results of these tests help establish specific welding parameters, which in turn are programmed into the master control unit. The master control unit is a combination of the latest solid-state and relay logic electrical circuitry, voltage requirements, travel speed, wire feed rate, oscillation width, dwell, and rate are programmed into the control unit for each pass of all 4 torches. A digital readout monitor permits the operator or inspector to compare operational conditions to preset parameters. The success of the automatic welding system on board the Viking Piper has encouraged H.C. Price engineers to look toward its use on the world's land masses. And although construction procedures for landline projects differ from lay barge operations, the Price equipment is easily adaptable for both. The same automatic welding features utilized successfully on the Viking Piper contribute to high production quality welding on land. The Price system is ideally suited for climatic extremes. The multiple pass capability allows an enclosed welding system to be positioned over the weld joint, and the weld started and completed within a controlled environment. Use of multiple machines along the pipeline right-of-way will accomplish high-quality field welding in a minimum amount of time. The H.C. Price automatic welding system represents a significant step forward in the advancement of welding technology. Automation, hand in glove with the welder, achieving quality and productivity to meet the highest standards. The H.C. Price automatic pipeline welding system. Technology with and for the man of the future.